Ladies and gentlemen, welcome to the second part of our last section in Chapter 8, 8.9, Perfect Squares. We're going to start with a little review, and then we're going to get into a little new material, and then that's going to be the end of the chapter. So let's try it. We're asked to factor the polynomial for number 1. Now with 4 terms, we want to factor, or we want to group like terms together. Well, we have an x squared here, so I'm going to group it like here, and I'm going to make this negative go with the 4x. So I'm going to group it like that, throwing a plus sign in the middle. So now in this first group, what can I take out? I can take out a x squared, and I'll be left with an x plus 2y. Now in this guy, what can I take out? I have a negative 4 and negative 8, so I'm going to take out that negative along with it and take out the negative 4, and so now I'll be left with here x plus 2y. So now can we keep going with this? Here we have an x plus 2y and an x plus 2y, the same thing, so I'm going to bring it down, x plus 2y. I'm going to put it right there. Now what do I have left over? I have a x squared that I didn't touch, and this minus 4, and then we close it up. Now can I keep factoring this red part? Can I multiply something times itself to get to x squared and something times itself to get to a negative 4? You bet. I can have an x, and then plus 2 minus 2 to add up to 0, to multiply to negative 4, also bring down the x plus 2y. So that was a review part. Now something a little new. Now we've touched on these, but I'm going to throw a little curveball at you on how to solve these. Now when we solve them, this trick will only work when we have just one variable, just one squared variable. Notice how we have just one squared variable here. So now when we do this, we want to get the variable and the number, this variable, on the other side of this, on the other side of the equation as 100. So what do I have to do with this 100? I have to add it to the other side, so it's on the other side of the equation. So I have 4x squared equals, and what's it equal? It equals 100, right? So I added it across. Now how do we solve something like this? Well, let's try to get this x squared by itself. And what can you divide by? I'm going to divide by 4. So when I divide by 4, I get x squared equals 25. Now here's the tricky part, guys. Make sure we're paying attention to this. X squared, how can I get those x's by themselves? Well, I am going to square root both sides, because a square root undoes a square. A square root undoes a square. A square root undoes a square. So now when it undoes a square, I have left an x equals, now the square root of 25, you can punch it in your calculator and you'll come up with 5, but what multiplies to 25? Positive 5 times positive 5 multiplies the 5, and negative 5 times negative 5 multiplies the 25, or you could write it like positive negative 5. So x here equals positive 5 and negative 5, and if you want, positive negative 5. So let's take a look at number 3. Right? Very first thing we want to do is make sure that we only have one x squared number, or one variable squared term. That we do. Now we want to get the number on the other side, so we put 80 on the other side. Now we have to get rid of this 5. We get rid of the 5 by division, so we divide both sides by 5. We are left with x squared equals 16. How do I remove a square? I have to square root both sides, and when I square root both sides, I'm left with x equals the square root of 16. What times itself is 16? It is 4, and that's a plus minus, because positive 4 times positive 4 is 16, negative 4 times negative 4 is 16. Jumping down to number 4. With 4, now we have the quantity b minus 7, and that quantity squared equals 36. We'll treat this just like an x squared or a variable squared. First thing I want to do is to get rid of this x squared. I repeat, the very first thing I want to do when I have a quantity squared is to get rid of the x, or get rid of the square. One more time. When I have this square, I want to get rid of it. And how can I remove it from the equation? I can square root this, and when you square root something, you have to do it to the other side to get b minus 7 equals, and then the square root of 36 is a positive negative 6, right? A positive negative 6. Now solving for b, we have to separate this a little bit. We have b minus 7 equals a positive 6, but we also have b minus 7 equals a negative 6. Very important that we have a positive 6 and a negative 6. Solving for both of those b's, we add these 7 over to get b equals 13. And then here in the red, we add the 7 over to get b equals 1. So now for number 4, we have two solutions. Those solutions are b equals 13 and b equals 1. Next with 5, again we have a quantity squared, and that equals 8. The quantity is all by itself, so we can square root both sides, leaving me with b plus 9. That equals, now it's not 4 because we're square rooting 8. What times itself gives you 8? And that's plus minus 2.828 after you type it into your calculator. Now we have to set this up and solve for b. Well, we have b plus 9 equals a positive 2.828, and we have a b plus 9 equals a negative 2.828. Solving, we subtract the 9 over to get b equals a negative 11.828 as I'm running out of room. And then for the red, we subtract it over to get b equal to a negative 6.17. So my two answers here are my two solutions here and right there. Next, last two. Here we have, or we're asked to solve, but it equals 0. Now we have 3 terms, so I cannot square root because I have 3 terms and I have this x, all right? I have this x and I have 3 terms. So what do we have to do? We have to factor. Remember, when we factor, does it equal 0? Yes. So now is there anything I can take out? Yes, there is. I'm going to take out a 4. All those numbers are divisible by 4. So I take out that 4. I put it on the side. I'm left with now x squared plus 6x plus 9. That equals 0. Now can I factor what's in the red? What multiplies to 9? What multiplies to 9 and adds up to 6? Well, that's going to be x plus 3 and x plus 3, and bring down the 4 because we didn't touch it. That equals 0. So now when we solve for this, we don't need the 4 because there's no variable attached. We can just go x plus 3 equals 0. I don't need to set this one equal to 0 because it's the exact same as that, so I just subtract it over. So x equals negative 3 after I subtract. And then one more with number 7. If we're solving for k, remember, we have another variable, so we can't square root right away. So now what can we take out? I look at all my numbers and all my letters. I can take out a 3k because 3k goes into all of those terms. So I will be left with now a k squared minus 8k plus 16, and now that equals 0. Can we factor still what's in the red? What multiplies to 16 adds up to a negative 8? Well, we have k, we're going to make my parentheses k and k. What multiplies to 16? Well, I know that's 4 and 4. What kind of 4 should they be when they add up to a negative 8? Both negative. Now here's the tricky part, bringing down the 3k. This all equals 0, but now we have k minus 4 equals 0, but we didn't have this touches 3k, but there's a variable attached, so we have to go 3k equals 0, all right? Very important. 3k equals 0, divide by 3, so k equals 0, add over the 4, so k equals 4. So we have two solutions for this guy, k equals 4 and k equals 0. And that does it for the second part of section 8.9, perfect squares. Good day.